So it's nice to be here. Today we are going to talk on this presentation about one project that I'm on. It's still ongoing. It's about the open source iterative resolution for event simulation. And I am part of the Center for Innovation in Modeling and System Optimization, CIMOS, from the Federal University of São João del Rei. Okay. Probably you never heard about this university, so I'm going to just a little introduction. I'm professor in the Federal University, and it's located in the state of Minas Gerais in Brazil. So it's a city with about 95,000 people and was founded on 1701. And the university itself, it has 6 campuses in 4 cities and 49 graduation courses, and about 13,000 enrolled students. And the majority of my time, I lecture courses in the production engineering course that each year offer 60 places for undergraduated, and now have about 380 students enrolled. So how all started? Sorry about the English. English is not my mother language, so if some typos or you don't understand something, please, I'll try my best. I undergraduated in production engineering in 2009, and I think most people, I had the first contact with Arena and OptiQuest. So there, everything was the beginning. I did my master in mining engineering, and that was the first attempt to try to unite Arena with an open solver, but I was not very lucky at that time. And then during my doctor in production engineering, I found a solution to my problem that was to use SymPy, a Python package for discrete event simulation, and I developed an solver in Python. Then I was able to have a grant for government research under FAPEMIG. FAPEMIG, it's a state of Minas Gerais development agency that financed the project. And I was able to start the OSIRES project that I revisited Janssen. At the time, I was very happy to see how Janssen have evolved and upgraded. So I decided to use Janssen for that project. And now I think that's however, I want to share one question with the audience. So how many open source simulation software do you know that have free distribution? It's associated with updated simulation open source modeler, have a support material, and have a user-friendly graphical user interface. So these were the main goals or attributions for this optimization software. So why open source? Why I decided to go open source on that project? Because it can be wide, and with free distribution, it's more easy to distribution to other people and even other people in other countries. Can have community participation, the possibility for scalability by being open to specific topics, in that case, operation research, and facilitate research in simulation and optimization. And with a great usability with a short learning curve when use advanced and modern optimization techniques. So these were some of the advantage of using open source software. The team that is responsible for this software, myself, Professor Wilson, Alex, and Luis, they were undergraduate students with at computer science course in my university. So what is the kind of problem that are supposed to be using OSIRES? Okay, thinking about an industrial scenario. In one industrial scenario, you have a number of machines, tools, operators, and okay, all kind of variables. If you think all the possible solutions, all the possible scenarios that you can think to test on a model or simulation model, you say that all of these solutions configure the possible space solution for this problem. So the main goal is to find a local optimum or maybe the global optimum for this with that represent the scenarios that best have the value for the problem that you want to resolve. So what is the OSIRES itself? Okay, I remember that I first read, I don't know if it was the Jameson user manual or in other texts, that Jansim have the ability to use the file to matrix block. And at that moment, it was something right at that document about integrating with a Python program. So I think, why not to try that? So Jansim, it's able to read CSV files for a number of scenarios that you want to test. And then after running all of the scenarios written at the CSV files, Jansim generates a DAT or data file with the variables that you want to Jansim to write at this data, at the run output of the Jansim model. So those arrows generates the scenarios right at the CSV file, call the Jansim without the graphical interface, only the command line, and then waits for the data file to be generated, read this data, and see which is the best scenario, and then takes this scenario for the best current solution, and then generates other scenarios to be written at the CSV files, and then it makes this cycle, this iteration, until the person says the programs to stop. At the current level of version 2 of OSIRES, it can be possible to use machine learning meta models along with meta heuristics for discrete event simulations models. It benefits from the right use of the meta heuristics and meta modeling with faster response that can be closer to the global or local non-optimum, and develop the research area by associating optimization methods with discrete event simulation. And with all of that, it's possible to make the methodology available free of charge to be used by the people interested in at this area. These were the 6 main screens of OSIRES. I will don't go at them right now. I will explain at the video that will come next slides. So just one simple example. Okay, I will not read this. I'll try to explain the next figure. Think about that parts arrive at some industry, and those parts have to be processed by two types of process. Have to be cut and have to be folded. And at this installation, it's possible to go to 2 different areas to be cut, and then to 2 different areas to be folded. So those parts arrived have 50% chance to go to one of those areas, and then go and have 50 chance to go to other one of the 2 areas. To the representation, the objective function, I want to maximize the output, the profit of this simple model. Okay, each product that goes to the end of the line, it is sold by 500 units of money. Then you have to take the cost necessary to produce it. That is related to the number of operators. Each operator costs 20,000, and you have the cost for waiting in line in the queues, and you have the cost for the time necessary in each station. For each of the areas, it is possible to place a maximum number of 50 people, 50 operators. So you have 4 variables: operators type 1, operators type 2, operators type 3, operators type 4, with a maximum value of 50 and a minimum value of 1. So thinking about the possible combinations for this problem, you have 50 elevated to 4, you have 6,025,250,000 possibilities for this problem. So it's practically impossible to you evaluate all of the possibilities of all the combinations that this problem can have. So I'm going to put a restriction to try to get it better. Okay, I'm at only the first configuration. You have the maximum of 200 operators. So I'm going to say no. For the size, for the total space of this operation, you can only have 100 operations. Even with that restriction of the problem, you still have a lot of possibilities. You have 3 million of combinations for this problem. So in this kind of problem, if you have a lot of possibilities to be evaluated, that you can try to use methods like machine learning, heuristics, meta-heuristics. I'm going to show the video about OSIRES. Okay, this is the welcome screen where you can load an already configured optimization file, or you can create a new optimization file. I loaded an already configured. In the second screen, you have to define the CSV file, the simulation model, the CFG, and the output data, the .dat file that you implemented for the model. So after the OSIRES read the CFG, the first line of the CFG, sorry, the CSV file, the CSV file is for the scenarios. So the first line have the name of the variables that you want to optimize. At this case, we have 4 variables. So for each variable, you have to define the minimum value, the maximum value, the steps that you consider between two responses to scenarios to be different. So one incrementation of one operator is considered for a difference between two responses. And some optimization methods use the initial value. Not all of them, but through a matter of configuration, you can put any value here. So for each one of the 4 variables, you have to define those bounds and steps. So the next, you can define the constraints of the problem. So to work with those constraints, the values have to be written at the .dat file. So if you want to use one variable of the GenSim, you have to specify as the run output of the module inside GenSim. So all of these variables were defined at the run output file. So I can use all of those variables to write constraints that will be evaluated for a feasible solution. So in this case, the number of operators cut type 1, operators cut type 2, operators fold, there is operators type 3 and operators type 4 have to be less or equal than 100. And this last variable will have to be always the objective function of the problem. So now you can define if you want to maximize or minimize the objective function and choose which optimization method you want to use, Ampere, meteoristic, or a meteoristic using machine learning. In this case, I'm going to use the GRASP meteoristic, the pure one. So the GRASP optimization started, and now the OSIRES is looking for the best solution in this problem. So after each iteration, it looks for the best solution and retrieves and save at the save file. So that was a short optimization run for this problem. This problem is kind of simple, and it was able to find a good solution near the best known solution for this problem. The best solution that I found at this moment was 2 operators type 1, 4 operators type 2, 1 operators type 3, and 4 operators type 4. The best known solution for this problem, it's 3 operators for all of the variables. So this was the OSIRES, and we are thinking about future work is to implement different optimization methods to make available other already tested optimization examples, to generate tutorial videos, more tutorial videos. There are just a few ones at the website, but we want to generate more tutorial videos about the methods and models. And one other project that we are developing, it's kind of in the beginning, but I think it's nice to mention that we want to make an open source probability distribution with a graphical interface for the jump sim. It's an ongoing project with the Federal University of Ouro Preto with Professor Cristiano Silva. The presentation references. I want to acknowledge for the OSIRES team that is in the meeting right now, for the jumps in development team that some of them I have the opportunity. It was nice to see your presentations yesterday and today. And for those who are making possible the first jump sim annual encounter organization, and for the present audience. So that was my presentation, and I'm open to talk, to answer any question.
Thank you, Wilson. Very interesting how you are able to optimize for a solution. I know that on the JomSim forum, some people have asked if there is an optimization function built in, and
Yes.
there is not one built into JomSim. Jason Smolinsky asked, what machine learning technique do you apply? Do you use MCMC, which stands for Markov Chain Monte Carlo?
Right now, I can try to open. I do not run the OSIRES at the moment because it costs a lot of resources to the program, to the computer that I'm using right now. But suppose that you use Scatter or Grasp, it is implemented right now, random forest, decision tree, k-neighbors, and gradient processor.
All right, thank you.
Okay.
Are there any more questions for Wilson?
So I guess the question is the AI method. What do you get in that drop-down box?
Okay, when we select a method with using AI, suppose like scatter, you can define which method you want to use. Suppose random forest, and then you can say how many simulation scenarios you want to train that model. Okay.
I see. Yeah.
Okay.
Neat. Thank you.
Okay. You're welcome.
Mark asked, can you show the GitHub repo again?
Oh, sure. The GitHub link have the latest one, and in the website you have the stable version at downloads.
I was going to ask you, so this is open source software where people can go and grab it, build a JomSim model, and then have it optimize for a variable or for optimize a outcome. So you could have, if you program into a model, optimize profit or optimize value, I guess measured in dollars, it could do that, or you could have it minimize something like time. So maybe minimize idle time or congestion.
Both of them. It depends how you construct your objective function.
Yes.
If you put variables that you want to minimize, so you choose to minimize. At the moment, you can use multi objectives objective function if you mix those type of problems. But at the moment, OSIRES can just maximize or minimize the objective function.
Okay.
Yeah.
Yes, that's very interesting. And then Dr. King has given a compliment. He's, obviously it's great to see how you integrate your software with JOMSOM, and thank you for sharing that. I think that's something that I'm going to go check that out, because I know that people have said, about optimizing, using some sort of machine learning feedback loop to drive a answer. Fantastic.
Yes, that's one of the main reasons I want to share with you what I'm researching right now, because okay, I have many ideas of what can be done in the future, but I don't know is that anyone want to use it or not. So if anyone in the audience or in later that will see this recorded video want to share some knowledge or try to develop some project, we are open to hear what you want to see next on OSIRES too.